merge sorted arrays. We have the two integer arrays, nums1 and nums2, in the ascending order, and then we have two integer m and n representing the number of elements in the nums1 and nums2. So so we have here is nums1 array and nums2 array, and our goal is to merge num1 into a single array in the ascending order. So merge this thing into one array in the ascending order. So the final sorted array should not be returned by the function, but instead stored inside array nums1. So it means that our nums1 have the length of n plus n. So m plus n for the length of the array, and m is represents for the elements in the nums1. So it means what it means, like here, if we have a nums1 equal 1 2 3, and num2 is 2 5 6. So the program will automatically give us the length of the num1 is like 1 2 3 plus 0 0 0, where 0 here is the n in the second array. So normally you can use the merge algorithm to solve this problem, where you can create a new array and then merge it into that new array, and then copy the new array into the nums1 and then return. But this can cause a big of n space. So instead of that, we can use a method like this. Let's see, we have 1 2 3 0 0 0 0 0. We have 2 5 6. So we can use we have two pointer, and we will point at the last index of each array, and then we can sort. So like if the right one, the under one here is bigger than the upper one, so we can change the location to 6 right here, and then we move from here to here. So when the under pointer here reach at the end of the pointer, so it means that our array is already sorted, so we can return the nums1. Okay, time for implementing the code. So the first thing is to two pointer in right equal n minus 1, in left equal m minus 1, and the last index equal m plus n minus 1. So while right is bigger or equal than 0, if left is bigger or equal to 0, and left left is bigger than nums2 right. So nums1 last index equal nums1 left, else return. So it means what? It means that if we have 1 2 3 4 0 0 2 5 6. So our two pointer will point into this, and the last index in will to this. So we will compare. So f3, because 3 is greater than and smaller than 6, so it means that we will move this into right here and move here. So our goal is to when this pointer pointing right here into the null, so it means that our loop is done and our rhythm is complete. So right here 5, so 3 is smaller than 5, so it means that we will move 5 into right here, 5 6 and 2, because 3 is bigger than 2, so we will move 3 right here. So our last index right here will move into here. So and then our left pointer is move this, and because 2 is equal to, so it means we will move to right here, so on and so forth, and then last we can our algorithm is already sorted this array. This way everywhere. Okay. Okay, here we go. Okay, time for analyzing. So because our code is if in the worst case, it means in the upper bound, we have to go through the left array and the right array, so it means that we have big O n time, and because this we're not creating any array, we just create some variable, so it's not ignore the constant, so we have big O 1 space complexity. So let's test this out. Right here. Oh, m in plus n. Oh yeah, I forgot. This means that n here is the length of the second array and m is the length of the first array. In the worst case, we have to go through two array.